Enthalpy change during phase transformations. Enthalpy of fusion. It is the change in enthalpy when one mole of a solid is completely converted into liquid state at its the melting point. H2O is to H2O liquid at 0 degree Celsius or 273 Kelvin. Del fusion H naught is equal to plus 6.0 kilojoule per mole. Enthalpy of vaporizations. It is the change in enthalpy when one mole of a liquid is completely converted into its vapors at its boiling point. For example, H2O liquid to H2O gas at 373 Kelvin. Del vapor H naught is equal to plus 40.79 kilojoule per mole. Enthalpy of sublimations. It is change in enthalpy when one mole of a solid is directly converted into vapors. For example, del sublimation H naught of iodine is positive 62.4 kilojoule per mole. Also, del sublimation H naught is equal to del fusion H naught plus del vapor H naught. Enthalpy of formations. It is the change in enthalpy when one mole of substance is formed directly from its the constituent elements in their most stable state of aggregations. C plus 2 H2G, C solid plus 2 H2G, CH4G. Del F H naught is equal to minus 74.8 kilojoule per mole. Hess law, Hess law of the constant heat summation. Hess's law of the constant heat summation. If a reaction takes place in several steps, then it's a standard reactions enthalpy is the sum of the a standard the intermediate reactions into which the overall reactions may be divided at the same temperature. Del RH is equal to del RH1 plus del RH2 plus del RH3. A spontaneous process, a process which takes place on its own without any external assistance. The driving force of a spontaneous process is large or finite. Carnot cycle PP AB isothermal reversible expansions A to B BC adiabatic reversible expansions B to C CD isothermal reversible compressions C to D DA adiabatic reversible compressions D to A DA adiabatic reversible compressions. Now Carnot efficiency N is equal to minus W total upon Q2 is equal to Q1 plus Q2 upon Q2 is equal to T2 minus T1 upon T2. Q1 upon T1 plus Q2 upon T2 is equal to 0 for a reversible cycle. Phi Q reversible upon T is equal to Q reversible upon T is equal to del S is equal to 0. Q1 upon T1 plus Q2 upon T2 is equal to 0 for reversible cycle. Phi Q reversible upon T is equal to phi del S is equal to 0. Here entropy denoted by S is a state functions. Del S is equal to integrations Q reversible upon T, the directions of a spontaneous process and that it eventually reaches equilibrium can be understood on the basis of entropy concept through second law of thermodynamics.